Hey guys, it's Danny. If you're watching this video, you're probably a lot like me when I was first learning how to code, right? I was doing all my boot camps, I was looking up all the YouTube videos in the world, but I still didn't feel like a bona fide software engineer. Better yet, I didn't even feel like a software engineer in trading until I was able to discover this one thing and this one paradigm shift that allowed me to adjust my studying accordingly to really start to become and develop the skills that I use today as a software engineer. And simply put, that one skill, we're going to get right into it. That one skill is being able to shift in your thinking from simply knowing how to code to actually thinking like a programmer. Now, I know that probably sounds a bit vague, like isn't that one and the same thing? How on earth could a programmer not know how to code? Or like, as I'm learning how to code, is it not with the goal of becoming a programmer? And so let me just kind of explain what I mean by that. You see, it's not simply enough to know the syntax of a language. Heck, it's not even simply about knowing the syntax to many different languages. If the way in which you construct and write your code doesn't meet certain criteria, you're never going to really truly master the field of software engineering at the level you're going to need to survive and thrive in a job. So to kind of help break this down, I have sort of three things that I would actually look into and spend some time curating and building out in my skill set as I'm going about learning how to code to really sort of shift my mindset from simply just knowing the basic syntax to actually being able to think and apply my code as a real software engineer might in a production level setting. And so one of the first things that I would recommend anyone, and heck, I would recommend this to myself if I could talk to myself from 3 or 4 years ago when I first started learning and teaching myself how to program, I would recommend having a good understanding, not a complete in-depth understanding, but a sort of surface to sort of like, I don't know, let's say a foot level deep understanding of the field of asymptotic analysis. Now, I know that's a pretty complicated word, right? Like, I mean, that sounds like something super scientific, and to a certain degree it might be, arguably, but essentially all asymptotic analysis is a simple study of how long it might take your program or algorithm to run. So the classic example that everyone will always teach you is, let's say you have some kind of list, right? In Python, it's a list. In Java, it's an array. Let's say you just have an element that can store different elements inside of it. If you need to perform an operation where you actually go across every single element in that list, that is what we would call a linear operation. And in asymptotic analysis terms, it would be called big O of n. And we can get into what asymptotic analysis is in a future video, but essentially what that means is as the length of your array increases, so will the length of time it takes for your program to run in a pretty much like diagonal y equals x type of pattern. However, let's say you need to do an operation in addition to each element, or rather, let's say for every element, you need to iterate over all of the elements again, creating what we call a nested for loop. Well, now the complexity in terms of time of your algorithm has just increased by the length of that array to what we would call big O of n squared. And so it now exponentially grows as the number of elements are added to your list. And so keeping this in mind, that simply just being able to do an operation that satisfies your goal on a data structure, for example, that's not enough. It should be efficient, especially if you're going to be building production level applications where there might be a consumer on the other end of whatever code you are writing. And I personally found once I started keeping this concept in the back of my mind as I was programming and working on projects, I really started to feel like I was kind of becoming that engineer that I had always dreamed of becoming, because I was now foregoing the simple solution to create a more sort of niche or a more advanced algorithm to be able to ensure I am keeping my time complexity at a cap. So that's the first thing that I would encourage everyone to take a look at to shift their thinking from beyond simply knowing how to code into thinking like a programmer. The second thing that I would also recommend you guys consider when writing code is maintainability. And so what I mean by that is just because you can do a certain operation that gets you the end goal for a algorithm, it doesn't mean it's the best one. And I know I kind of just said that with time complexity, but it is also true when it comes to scaling, right? Let's say in the future, I don't know, 5 years from now, 5 months from now, 5 hours from now, there's another variable that gets added into like the ecosystem in which your algorithm thrives. Well, depending on how you constructed that algorithm or that program, you might need to go in and refactor and do all kinds of crazy manipulations because you made your code too specific the first time you wrote it. And so what I found to really sort of level up my ability to code as a software engineer was possessing and keeping in mind this idea of how will this impact changes in the future. And to be fully transparent with you guys, this is something I'm still working on today. I get feedback all the time from coworkers I work on saying, hey, maybe you should do it this way. So this way, if something else changes in the future, you won't have to come back to it, but you can just simply handle it now. And so while that inevitably makes it longer to write programs, it really does help you think more like a programmer because you're now going to be smarter in the ways that you construct your applications. You're now going to be, when I say wiser, when it comes to thinking about what can happen in the future if a new variable is introduced. And so keeping that and coupling that along with asymptotic analysis in terms of like time complexity, that's really going to start to build out your overall thinking like a programmer framework. And it's really going to be valuable to any organization you are in, because let's face it, every organization has bad code that is written. We all write bad code from time to time, but the idea is the more you keep these in the back of your minds and the more practice you get, the more these things will just become second nature to you, and you can just simply increase and build on that base that you have already laid because you studied in the right manner. And the final way that I would say you can start to think more like a programmer as opposed to just simply knowing how to code is to code with clarity. Now, because of all the idiosyncrasies that are involved within every single programming languages, there's like an infinite number of ways to write things. But coming up with a sort of standard way of how you write things, and borderline what I would argue almost like your own art form when it comes to how you write clean and readable code, is going to be huge when you get into an entry-level role or even to advance beyond what you're currently doing in your current role. Believe you me, I have run across many a times unreadable code in different code bases, and it always frustrates me that the person on the other side didn't necessarily take the time to deeply understand, hey, maybe someone will come back and read this one day. Now, to be fair, I've also done this to myself. I've also written code months ago that when I come back to it now, I'm like, oh my gosh, what on earth was I thinking when I even wrote that in the first place? And while I can't tell you and probably remember what I was thinking, I can definitely tell you what I was not thinking. And that was, I should probably make this readable for me when I come back to it inevitably in the future. And so that's kind of the final thing I would say really kind of shifted my framework from just simply beyond knowing how to code into thinking like a programmer. And if you combine those and all three of these things together, you are just simply, it's inevitable that you will become a more proficient and efficient software engineer. And if you are aspiring and trying to break into the software engineering industry, I feel like this is what is going to take you to the next level in terms of finally laying down a good foundation of coding and best practices when it comes to being a software engineer. Now, in terms of like what are different resources that you can use to help you with all these things? Well, for clarity and maintainability, I would say definitely for clarity, just work on projects. Like whatever project you're working on, maybe go back, refactor it and say, hey, like if someone else had to read this, is it specific enough for them to go through it in an easy manner? Like, shoot, is it readable enough for me to go through it in a couple of months from now? And so that's one way I would probably work on my clarity. In terms of maintainability, work on a couple projects with some people, right? Like if someone else introduces something and you guys are like using GitHub and they push a piece of code that sort of breaks what you have written, maybe think, okay, well, how can I make it next time so that when they push a change, it won't break with my system because I already tried to account for that previously. And while it might take some more time to create the algorithm or application you need, it's going to be well worth it, and it's just great practice for when you're in a production level setting and getting paid as a software engineer. And trust me, your coworkers will appreciate it immensely if you can go ahead and write your code clearly and also in a maintainable way. And finally, in terms of asymptotic analysis, I would highly recommend LeetCode. LeetCode is an amazing website. On this YouTube channel, I reference it all the time. You're going to want to get intimately familiar with it, especially if you're in the job hunt for any type of role in tech, or if you want to make the transition from a different point in your career. I would highly recommend that website. They have a great data structures and algorithms program that will teach you asymptotic analysis at a very good level. And so with all that being said, guys, honestly, that is the one thing that I felt helped me become the software engineer I am today, is when I had that paradigm shift that I need to go beyond just simply knowing how to code into thinking like a programmer. And those three things of asymptotic analysis, maintainability, and clarity are what I feel helped me sort of solidify that shift and ultimately landed me the job that I have currently today. But that's going to do it for this one. If you guys enjoyed this video, be sure to smash that subscribe button. If you guys are interested in becoming a software engineer, specifically in the Python programming language, I do offer a coaching and course program where I can actually help you walk through what it takes to learn Python, master it, and at least to the skill level that a job would require, as well as to help you walk through the job hunting process. So I will go ahead and link that down in the description below this video. If you think you're interested in that, feel free to book a call, put it on my calendar. I would love to know how I can help you. But thank you guys so much for watching, and I will catch you all in the next one. Later.